All right, guys, just a quick recap before we go through the exercises together, which was supposed to be a homework. Basically, last week we learned about the three main types of thermal processes, right? Mainly being conduction, convection, and also radiation here. Now, I've mentioned that for conduction to occur, usually it must involve a third-party object. In this diagram here, obviously the handle of the pot is going to be the third-party object here. The heat from the water is conducted to the handle and then finally conducted to your hand. That's why you can feel the heat. Whereas convection, we basically stated that heat always travels in the upwards direction, right? That's why when you put your hands above the fire, you will always feel that it is much hotter on top. It is simply because convection is forcing all the relatively hotter particles upwards and ultimately displacing the colder particles downwards, guys. Then we also learned about radiation. Radiation is one of the only thermal transference which can transfer through a vacuum, meaning to say the heat is radiated from the sun to earth through space. It does not require a medium. Radiation is the only heat transference that can travel through vacuum, guys. Very important for this part here. Right. Then after that, we also talked about good and bad insulators. Mainly good insulators are things with very low specific heat capacity. For example, metals. Any form of metals are generally good conductors of heat because of their free moving electron, guys. We mentioned about the free moving electron, which is responsible for conducting heat and also electricity, guys. Then, of course, insulators are things that do not transfer heat, right? For example, wood, plastic, and sand. All these kind of things are generally things that do not transfer heat easily, right? But they will still have electrons, just that the electrons are embedded into them already. They don't have free moving electrons here, guys. Wood, plastic, sand, rubber, glass, wool, all these kind of things are generally considered good insulators, right? Then after that, we also talked about a simple experiment to demonstrate which one could be a better conductor of heat. Basically, you have four different metals, right? All heated up at the same time by the same heating source, right? And then at the end of each and every one of these metals here, they kind of stick a Vaseline onto the end, right? So basically, whichever one has the greatest conduction of heat will conduct the heat fastest towards the end and then melt the Vaseline and drop the drawing pin. From here, last week we mentioned that copper is actually the best conductor, followed by aluminum, brass, and finally steel, right? Then this part here is basically the molecular account of how heat is conducted. Usually it is through the transference of energy. For example, if there is a heat source here, this guy is going to vibrate, pass on energy, vibrate, pass on energy, vibrate, pass on energy, vibrate, pass on, and so on, so on, so on. So that is why heat is always transferred from hot to cold, and guys, yeah. Now, after that, in terms of convection, if we were to talk about it in terms of density, guys, always remember that when you're heating up any particle, it is actually going to cause it to expand and its volume will increase. Once the volume increases, the density decreases, right? And this causes it to float upwards. When it floats upwards, what's going to happen is the relatively colder particles will displace downwards and replace the hot particle, and the whole process will repeat again, right? It's basically going to be like a convention of heat here, right? Then, yeah. Finally, we also talked about radiation, which is due to infrared, guys. I think I highlighted this last week. I need you guys to remember this again. As soon as you see the word infrared, right? Infrared is responsible for anything that is hot, guys. For example, the sun is hot because of infrared radiation. Your stove is hot because of infrared radiation. Anything that is hot must be because of infrared radiation, right? And then finally, we also learned about the black, white, and silver here. Black, white, and silver, mainly we talked about reflectors and absorbers, right? Reflectors and absorbers basically says that silver will reflect most of the heat, whereas most of the heat emitted onto the black surface will be absorbed inwards, right? Then emitters are basically those that emit heat outwards, guys, right? So in general, if you have a good emitter of heat, you will emit heat outwards here, right? It's going to admit this heat outwards. In other words, the better emitters are generally the ones that have a relatively higher temperature when you read it, guys. That's why you never wear a black color t-shirt into the beach, because you know it's just going to absorb most of the heat, right? Then this is just a simple experiment to demonstrate how the black, white, and silver surfaces actually absorb and emit heat back outwards, guys. Right. I think shouldn't be a problem for this part here, right, guys? Let's move on directly into the questions from last week. So if you were to look at all these questions from last week here, kind of a show of hands of how many of you guys actually did the homework. How many of you guys actually attempted the homework at all? Any one of you guys attempted it? Wow, no one attempted the homework at all. If you guys did not even bother attempting it, then you will have to attempt it right now already, guys. Seriously, no one attempted it. But I can kind of understand some of you guys are in the holidays already, right? Yeah, I think some of you guys are on the holidays already. So, yes. Oh, hi, Xuan Xuan. You are late for class.
Hello.
你在 center 了是吗？ Yeah. We're going to be going through exercises, Xuan Xuan. Gilbert 有在那边吗？现在？
Yeah, send it to me. Send it to me.
Let me send it to you, Gilbert, and ask him to print it out for you. We're going to be doing some exercises. It's in the group chat, Gilbert. Okay, for everyone else that is here, I want you guys to attempt this first question, guys. Yeah, I'll give you guys 5 minutes for this part here. Then after that, we'll discuss the answers immediately after 5 minutes. Can you guys do that right now? Okay, everyone. I think you had sufficient time to read the question and attempt the questions. Let's go through it together. Then after that, maybe you can do the next one on your own. Okay. Everyone, please pay attention. All right, if you look at the first question here, figure 5.1 shows some apparatus designed to compare the ability of two surfaces to absorb infrared radiation. Basically, the question here starts off with this one has ability and this one has a different ability to absorb infrared, which is essentially heat, right? One is painted dull black, the other one is painted shiny white. The containers which are identical are painted on the outside. One is dull black, the other is shiny white, both filled with water initially at the same temperature. So these two are both filled with water initially from the same temperature. Then this is what the question wants from you, guys. Describe how you would use the apparatus to compare the abilities of two surfaces to absorb infrared radiation. Basically, this question here is asking you, how are you going to use this apparatus here to show that black color is the better absorber of heat and white is the worst absorber of heat, right? So they give you all these lines here, right? You're basically supposed to tell them what you're supposed to do, guys. So if I were to conduct this experiment, first and foremost, I'm going to put a Bunsen burner in between these two surfaces, making sure that both of them are equal distance apart, right? And then I'm going to measure the initial temperature before it is heated. And then after a certain period of time, let's say, for example, after 5 minutes, I want to measure the temperature again. Whichever one has the higher temperature is the better absorber of heat. So this is how I'm going to tell them what I am going to do with this apparatus to measure better absorbers and worse absorbers of heat. All right. So if I were to structure that in words, it will be something like place the Bunsen burner in between the two surfaces at equal distance. Measure the initial temperature before heating and measure the final temperature after heating. Whoever has the higher temperature is the better absorber of heat. Okay, guys, so basically you can structure it in any way possible, right? Like I keep saying over and over again. It doesn't necessarily have to be like this, but the keywords are basically there, all right? First and foremost, this is one of the keywords. They must be equal distance, right? I can't have this one 10 cm away and this one like 5 cm away, right? Then the radiation heat is not going to be the same. The initial temperature should be taken just to make sure that they are for sure the same temperature, right? And then I'm going to measure the final temperature after heating. Whichever has the higher temperature is definitely going to be the better absorber of heat, okay? I'm gonna just copy this down into the chat box. Anyone's got any question with this? Anyone don't understand what I'm talking about with this answer here? Yeah, if you don't understand, just unmute yourself and ask your question, guys. If not, I'm just gonna assume that you understand. Then after that, of course, state the result that you would expect here. Obviously, you're gonna say that black has a greater increase in temperature. Something like that, right? Obviously, you know that black color is the better absorber of heat, and thus it should have the greater increase in temperature. Okay. Anyone's got any questions here? Good. Excellent. If you have no questions, then yeah, can you guys proceed on to do this part as well? As same thing again, 5 minutes, guys. Please attempt these questions and answer according to what you know. All these are just 1 mark questions, guys. Please attempt it so that you know what you don't know.
Teacher, can you show again the answer for question 8?
Oh, I typed it on the chat already.
Okay.
Yeah, you can refer back to the chat next time you scroll up. Do you see the? Can you see it?
Yeah.
Yeah. Yeah. If you guys need to copy or take time copying next time, just refer to the chat. Hey, Chen, which chapter are you right now in school, by the way?
Chapter.
Uh,
I'm not really sure. I need to check back.
Yes.
Yes.
Are you guys done with, okay, there's six main topics for your years. General physics, where you talk about force, momentum, moments, pressure, energy. Then the second chapter, which is what we're doing right now. We finished the second chapter already, which is thermal physics, expansion, conduction, convection, radiation, Q equals to MC, theta, latent heat of fusion, all those kind of things, specific capacity. Have you learned this in school already?
Yes.
So you're in wave chapter, is it right now? Wave physics? Are you learning anything in waves or electricity already?
Because I'm in year 9, so we don't really have the book.
You're in year 9. Okay, never mind. I'll talk to you next week when I'm at the center. Yeah, I'll talk to you next week. All right, man. Anyways, hey guys. If you look at this part here, this is basically what we learned in chapter 2.2, right? Basically, it says that the thermometer uses a high sensitivity and linear scales. Guys, if you refer back to my notes, guys, for high sensitivity and linear scale, sensitivity is basically the ability to measure small changes in temperature, right? Whereas linear scales are basically equal distance between each reading. That's why we use mercury or alcohol, right? So from here, they say that they ask you to state what is meant by high sensitivity. You could either write the ability to measure small changes in the temperature, or you could also say something like small change in temperature leads to large change in reading. Guys, if you look at the mark scheme later on when you're doing the past year papers, you'll notice that these two are always the standard answers for sensitivity, guys. And in this question here, all right, usually we are going to use a high sensitivity thermometer. Why? Because like I mentioned, guys, even though we know that dull black is the better absorber of heat and shiny white is the better reflector of heat, even though it absorbs more heat, the temperature difference will be very, very small. For example, if let's say here is 90 degrees Celsius, right, for the dull black, this one won't be very far off only. It will be somewhere like 89.5 degrees Celsius, right? Because the difference in the reading is very, very small. That's why we must use all these high sensitive thermometers, guys. Always remember that. So obviously the ability to measure small change in temperature is needed. And this is just the standard definition for high sensitivity. Small change in temperature leads to large change in reading. All right. And then followed up by the next question here. Explain what is meant by high sensitivity. Why a high sensitivity is important for this experiment here, right? This is essentially what I mentioned just now, right? Because the difference in temperature is very, very small. If you do not have high sensitivity, you cannot even measure the difference between them. You're supposed to say something like difference in temperature between black and white is very small. A high sensitivity is needed to okay. Right. Then finally, what is meant by linear scales? Linear scales, it means to say they have equal distance between each reading. Guys, remember a linear scale will look something like this, like it'll be like 1, 2, 3, 4, 5, 6, right? A non-linear scale will be like 1, 2, then 3, then 4, then 5, somewhere here, guys. These are what we call linear. They have equal spacing between each reading. These are definitely non-linear. They don't even have equal spacing between each reading. Right. Oh shit. Then, so from here, your answer will be the same thing. Equal spacing between each reading on the third. Okay, guys. Anyone's got any questions from this part here? Okay, great, excellent. If you have no question, then let's move on to the next part here. Guys, I want you guys to do this full question here, guys. It's gonna take a bit longer because it's a much longer question. Then after we'll go through our ABCs. This question here, this question is quite similar with the first one we did just now, guys. I want you guys to attempt it on your own, right? Then after that, we'll discuss the answers. After a certain amount of time, how many marks here? There's going to be 6 marks here. So let's do it after 8 minutes, guys. 11:40. Please attempt this question, guys. By 11:40, we'll discuss the answers. And for those who are done earlier, you can always type me your answer, then I can give you a few comments on whether your answer is on the right track or at the wrong track of the mark schema, guys.
Teacher, I don't understand question P3.
Question B, this one.
No, question 4.
Question 4. Which one? This one?
4B3. Or the state what is meant by a linear scale.
State what is meant by linear scale. Is it this one?
Yeah.
Okay, a linear scale, right, is basically a scale that has linear distance between each reading. You know, for example, right, if you have a look at your ruler, you'll notice that your ruler is going to be like 1, 2, 3, 4, 5, 6, 7, 8, right? It will be always equal distance apart. This ruler, we say that the scale here is actually linear, meaning to say the distance between 1 to 2, 2 to 3, 4, 3 to 4, 4 to 5, and 5 to 6, right? The distance are always the same. This is what we want in a thermometer, because usually inside a thermometer, right, we have these liquids known as alcohol or mercury. You know, this alcohol or mercury, right, they will actually expand linearly with temperature, meaning to say, right, let's say, for example, initially here is 0 degrees Celsius. If I increase the temperature by 1 degree Celsius here, the mercury would have expanded by 1 cm. If I increase the temperature by 2, the mercury would have expanded by 2 cm. If I increase the temperature by 3, the mercury would have expanded by 3 cm. So every time you see that the liquid level rises equal linearly with the temperature, right? This is what we call linear scales, okay? They must have equal distance between each reading. A non-linear scale will be, if imagine you have bought a very shit ruler, right? Then you're going to be like 1, 2, then 3, then 4, then 5, then 6, and somewhere along here, right? So this is a non-linear scale. You get what I mean?
Yes.
Yeah.
Okay, thank you.
So you just copy this down first and start attempting some of this. Are you just done copying, by the way?
Teacher, I sent you our school city just
You send what?
now. I sent you the formula.
Oh, okay, right. Let me have a look. Yeah, these are mostly general physics, basically. I think they're trying to prepare you guys for year 10's first chapter, this one. Yeah. I'll send you a video to watch later, a few videos to watch later. And after that,
Okay.
yeah, you can catch up a little bit. Okay, guys, has everyone taken the time to attempt the questions? Let's go through it together, shall we, everybody? Okay, so if you look at this question here, right? This is that figure 5.1 shows some apparatus which is to be used to compare the emission of infrared radiation from 4 differently painted surfaces. Yet again, you see the word infrared, which means to say they're trying to see which one is hotter, right? And then there's 4 different surfaces. One is dull black, one is shiny white, one is shiny black, one is dull white, which is quite redundant, I would say. Then after that, near the center of each side of the infrared detector, the 4 detectors are identical. So basically, there's going to be an infrared detector, which in other words is just a thermal gun, right? To measure how hot this side is, how hot this side is, how hot this side is, and how hot this side is, most likely, right? Then after that, a supply of very hot water is available. Okay, so this time they did not say that they pour it in. They give you a supply of hot water, right? Then after that, they say describe how you would use this apparatus to compare the infrared radiation from the 4 surfaces here, right? So basically, yet again, you're supposed to describe how am I going to use this and also this detector here to determine which one is the best absorber and also emitter of heat, right? So if I were to do this, I'm going to say something like this, right? Yet again, initial temperature of each side of the box is taken. Then after that, very hot water, the hot water, right? The hot water was poured through the hole on top, through the hole on the top, and the heat from the water was left to stabilize for maybe 5 minutes, right? So basically you pour the hot water in and then you wait 5 minutes before, after the 5 minutes, the temperature was recorded on each side after 5 minutes, whichever, yet again, has the highest increase in temperature is the better emitter. So yeah, this is quite a lengthy one, but it's 3 marks, guys. So basically, you're describing what you should do with these apparatus and how you're going to conduct this experiment, right? You're going to measure the size of each different color first, right? Making sure that they're all the same. Then after that, you're going to pour the hot water in, you let the heat stabilize for a while. After 5 minutes, you measure the temperature again. Whichever one has the greatest temperature is obviously going to be the better emitter of heat. Okay, guys, anyone's got any questions from this part here? Give me a minute, I got a phone call. All right, sorry guys. I have a dilemma later on. But anyways, yeah, from here, anyone got any questions or not for this part here? Everyone understand what I'm talking about, right? And from here, the next question asks you which surface will be the best emitter and which one will be the worst emitter. Obviously, you're going to say the dull black. Dull black is going to be the best emitter of heat. Like I mentioned again, emit means to say is radiating heat upwards. That's why the thermal gun can detect the heat, guys. The dull black is definitely going to be the best emitter of heat. And of course, the worst emitter is going to be the shiny white, right? Because white in general reflects most of the heat back, guys. All right. Then finally, the last part here, they ask you to draw and label a thermocouple, right? For those of you who have forgotten, a thermocouple consists of a few main parts, guys. This is definitely going to be the galvanometer. Like I mentioned again, the galvanometer is basically something that can measure millivoltage and milliamperes, guys. You cannot use a voltmeter or can you use an ammeter. It must be a galvanometer or a millivoltmeter or a milliammeter for a thermocouple. And after that, there's going to be metal X here. There's going to be a hot junction here. There's going to be a cold junction here. And there's going to be a different metal Y here, right? Now, of course, you're going to label everything. You're going to say like, this is like, yeah, this is obviously going to be a galvanometer. This is going to be a metal X. This is going to be a metal Y, and this is going to be your hot junction, and this is going to be your cold junction, guys. For the full diagram, please refer back to your notes, guys. I don't think I need to draw everything and label everything nicely again for you guys. But if you're asked to draw, you could draw this and label everything. It should be good enough, guys. All right. But for Swen's case, you're definitely going to be like super confused. I don't think I don't think you've ever seen something like this before. I'm gonna send you a few videos later. You can watch. You can watch it. All right. Yeah, but anyone's got any questions from this part here? Good, excellent. Can you finish the last one here? Now after the ABC before we end class today, guys. Can you finish this one here? Right, this one here and this, wow, all this in 5 minutes. Do you think that's possible? Most likely not. Hey, finish this in 5 minutes, guys. Then we'll discuss the answers. Hurry up. Time is running low already. Okay, everyone. Due to the time constraint, of course, we will have to discuss the answers immediately, guys. Please check and see if you are in line with what you're supposed to know. If you look at this question here, what do they want? Figure 5.1 shows two identical metal plates. The front surface of one is dull black yet again, and the other one is shiny silver. The two plates are fitted with heaters that keep the surface of the plates at the same temperature, right? So basically this whole surface is the same temperature, this whole surface is the same temperature. Then after that, state the additional apparatus needed to test which surface is the better emitter of heat radiation. Guys, in this experiment here, they only give you these two things. And if I look at this question here, they're asking me what apparatus is needed to test out which one is hotter. Now, obviously, it could be anything that measures heat, right? For example, a thermal gun or a thermocouple. Probably not a thermometer because you're not going to place a thermometer on the side here, right? It's a bit weird, right? So I think a thermal gun would definitely be a safe answer here, or even a thermocouple, thermal gun or thermocouple. And for those who do not know what a thermal gun is, it's basically the ones that you scan in the shopping mall, right? They scan ahead and you can see how much temperature. That is a form of a thermal gun as well, guys. Right? Then, of course, next, state one precaution that is needed to ensure a fair comparison. Now, this is quite a thematic question, guys. I mean to say, every time when there is these kind of heat questions, these kind of questions will usually pop up. I want you guys to always remember that when you're dealing with anything that is hot, right, in order to make sure that this experiment is of fair comparison, we must ensure that the conditions are the same. For example, if I measure this dull black in a room without wind, then I must measure this shiny white in a room without wind. If I'm measuring this with a thermal gun 5 cm away, I must measure this thing with the same thermal gun, which is also the same distance 5 cm away, guys. Then this way I'll ensure that it is a fair comparison for the experiment. So you can write down anything, right? You could write down something like ensure the experiment is conducted in the same room, make sure that it's without wind, or make sure that the thermal gun is same distance away from when measuring both the surfaces. Ensure that the thermal gun is same distance away when measuring surfaces. Anything that's logical is definitely acceptable, guys. And finally, state the results you would expect. Obviously, the black will have a greater temperature reading. And right now, another name for heat radiation, that is basically what we call infrared radiation, guys. Like I keep saying, anything that is to do with heat it must be because of infrared radiation, guys. And then finally, the last part here, draw a label diagram of any situation where convection current occurs. I mean, you can refer back to the notes here, right? You could have either drawn this, which is your Maggie Me story, remember from last week, or you could have drawn this, which is essentially the tectonic movement of the plates, or you could draw this, which is the same thing, or you could have drawn this, which is also the same thing, right? Either one, just draw anything. But don't take your sweet time though, because your exam there's limited time. So you probably just want to draw like a pot, then you want to separate it into half, then you say like this is water, then it's the hot particle, which is obviously colored in red. There's a relatively colder particle here, and then you circulate one up and you circulate one down, right? Now you of course say that this is your heat source lah. And label everything lah. This is your hot particle, this is your cold particle, and this is your water and pot and whatever. You label everything, then you get your easy free marks here. Okay. Anyone's got any questions from this part here that they don't understand? Okay. Yeah, for those who are still here, guys, I noticed some of you guys did not do the Google Sheet questions, or have I not even given you the Google Sheet questions? Let me check. I think we did a little bit last week, right? Yeah, we did, right? Yeah. But most of you guys did not do the last ones. Oh, Raj did. Is you, Raj? It's not right. Very good. Let me resend you guys the link again, guys, as homework. Please make sure you do it. Always remember, the homework is for your sake. It's not for me. I'm not the one going for the exam. I'm going to send it into the WhatsApp question, guys. Yeah, Shen, that's correct. That's acceptable. Raj, do you want me to send you the links again? Please make sure you go do it since you're not in the group chat. Here, let me send it to you once again. Yeah, please do the Google Sheet questions, guys. Yeah, I sent you the third and the fourth one. Guys, please make sure you go do the Google Sheet questions, because this one here is one of the easiest way to tackle the topic one by one, guys. Next week, when we come back, we're going to be doing some questions in class for the whole thermal physics. Then after that, the following week, you guys will be tested on thermal physics already, guys. Remember, next week is revision. Then the following week is going to be a small little test to see how well or how unwell you guys have come from the thermal physics chapter, right? Yeah. If you have any other questions, feel free to ask me right now. If you have no questions, that will be it for the day. Enjoy your weekend, boys and girls. Oh, for the anyone that got a question, you can stay back, guys.